In this video, we discuss how to use GeoGebra to calculate normal probabilities for the sampling distribution of p hat. The directions are given here, and we'll use the example found below to illustrate how to use GeoGebra. According to the Congressional Research Service, 64.9% of Utah is federal land. 100 locations in Utah will be randomly selected and checked to see whether they are federally owned. Describe the sampling distribution of p hat. The mean of the sampling distribution of p hat will be the same as the population proportion, 0.649. The standard error for p hat is given by the expression square root 1 minus p divided by n, which is approximately 0.047728. The shape will be normal if two conditions are met. The first is NP has to be greater than or equal to 10. N is the sample size, 100. P is the population proportion, that's 64.9, which is greater than or equal to 10. So our first condition is met. The second condition, n times 1 minus p, has to also be greater than or equal to 10. So that's 100 times 1 minus 0.649. So that's 100 times 0.351, which is 35.1, which is greater than or equal to 10. So both of the conditions are met, which means the shape will be a bell-shaped curve or the normal distribution. So it will be a normal bell-shaped curve. So because it's normal, we can use the normal probability calculator in GeoGebra to calculate certain probabilities. So for example, the probability that p hat is less than 0.6, we can do this in GeoGebra. So we open GeoGebra, we go to the probability calculator, we go to distribution. This is the normal curve, so it's already open for normal. We'll put in the mean, 0.649, and the standard deviation. Now here you can put in the approximate value that we found before, 0.047728, or you can put the entire expression in. Putting in the entire expression will give you better answers with less rounding error. So it's a good thing to know how to do. So to enter in the radical symbol, we can type SQRT parenthesis and then put 0.649 times. So I'm putting that expression that we had on the other page directly in as follows. So that gives us our standard deviation right away. Then to find the probability that p is less than 0.6, we'll go to the less than, we'll put in 0.6, and we have our probability, 0.15229. If we want to find the probability that p hat is greater than 0.7, we go back to GeoGebra, we change the bracket to greater than, put in 0.7, and we get our probability 0.14264. So in GeoGebra, before we put in this entire expression, let's do that again with using the rounded value for the standard error. So instead of putting in the entire expression, we can use the rounded value. And we see it actually gives us the same answer, at least to the 5th decimal place. So sometimes it makes a slight difference, sometimes it doesn't make much difference at all, but it's good to know how to use that exact expression when calculating probabilities using GeoGebra.